everyone. In this video, we will solve an example problem in Chapter 2, which is about the pure substances. Water is to be boiled at an elevation of 1,500 meters where the atmospheric pressure is 84.5 kilopascals, and thus the boiling temperature of water is 95 degrees Celsius. The water is in 30 cm diameter stainless steel pan placed on top of a 3 kilowatts electric burner. If 60% of the heat generated by the burner is transferred to the water during boiling, determine the rate of evaporation of the water. So based on our problem, the water is boiled at 1,500 meters at a pressure of 84.5 kilopascals, which is placed on top of a 3 kilowatts electric burner that transfers 60% of the heat generated to the water. So the rate of evaporation of water is to be determined. So before we will proceed in finding the problem, we will first identify given in our problem. So we have here the elevation, which is equal to 1,500 meters, diameter, which is 30 centimeters, the power supplied, which is equal to 3 kilowatts, the heat, which is generated by the burner, which is equal to 60%, and at 84.5 kilopascals and 95 degrees Celsius, the difference in enthalpy between the saturated liquid and the vapor states is equal to 2,269.6 kilojoules per kilogram. So this data can be obtained in the property table from table A-4. So the rate of evaporation of water is to be determined. So the rate of evaporation of water is given by the evaporation mass flow rate is equal to the rate of heat transfer all over the difference in enthalpy between saturated liquid and the vapor state. So since the rate of heat transfer is unknown, we must find first this unknown. So the rate of heat transfer is given by the heat generated by the burner multiplied by the power supplied. So 0.60 multiplied by 3 kilowatts. So we have now the rate of heat transfer, which is equal to 1.8 kilowatts. So now let's proceed in finding the mass flow rate of evaporation of water, which is equal to the heat transfer rate all over the difference in enthalpy. So plugging in the values in this equation, we will now have 1.8 kilojoules per second, which is equal to kilowatts, all over 2,269.6 kilojoules per kilogram. So plugging this in the calculator, this will result to 0.793 multiplied by 10 raised to negative 3 kilogram per second. So this will result to 0.000793 kilogram per second, and then we will convert this into kilogram per hour. So there are 3,600 seconds in 1 hour. So we will multiply this by 3,600. So seconds here will be cancelled. So we will now have the mass flow rate of evaporation of water, which is equal to 2.855 kilogram per hour.